this video, I am going to discuss about atomic hydrogen welding process. Short form is AHW. See, we have already discussed about gas welding process and arc welding process. In gas welding process, the heat required for welding is obtained from burning a fuel gas in presence of oxygen. Oxy-acetylene welding process is an example for gas welding process. In arc welding process, heat required for welding is obtained from electric arc created between electrode and workpiece. Or otherwise, the heat required for welding is obtained from electricity. In arc welding process, source of heat is electricity. Low amperage, high voltage electricity. See, atomic hydrogen, the entire process is different. Atomic hydrogen welding is a thermochemical welding process. See, in atomic hydrogen welding process, electric arc is created between two non-consumable tungsten electrodes. The energy of the electric arc is not used for welding process, melting the base metal to be jointed. Hydrogen gas is passing through the welding area. Basically, it acts as a shielding gas, and also by absorbing the energy from the electric gas, hydrogen molecules converted into ions H plus and H minus. So H2 is converted into H plus and H minus by absorbing energy. When these hydrogen ions contacting with the cool metal, base metal, these hydrogen ion recombine. That is a exothermic reaction. First one is an endothermic reaction. Second one is an exothermic reaction. Exothermic reaction means liberating heat energy. When these hydrogen ions recombine to form hydrogen molecules, large amount of heat will be liberated, and the temperature producing will be approximately 4000 degrees Celsius. That temperature will be used for melting the base metal to be jointed. So that's the basic principle of a atomic hydrogen welding process. See, atomic hydrogen welding process le gas welding poleyo arc welding poleyo alla heat welding ulla heat obtain cheyunu. So initially we are using a non-consumable tungsten electrodes. An arc will be created between the electric arc will be created between the tungsten electrodes. But energy from the electric arc is not used for welding process. It is absorbed by the hydrogen gas supplying nearby welding area. By absorbing this hydrogen gas, hydrogen molecule is converted into hydrogen ions H plus and H minus by absorbing energy. That is an endothermic reaction. And this hydrogen ion, when contacting with the cold metals, base metal to be jointed by welding process, the recombining these ions to form hydrogen molecule H2 by liberating heat energy. That is an exothermic reaction. That heat energy is used for melting the base metal to be jointed, and the additional metal that is known as filler material is adding separately by using filler rods. So this is the principle of an atomic hydrogen welding process. See, this is a figure of atomic hydrogen welding process. Atomic hydrogen welding process consists two non-consumable tungsten electrode. See, these are the two non-consumable tungsten electrode. AC power source is used, and there is a hydrogen cylinder which will provide hydrogen shielding gas nearby welding area. So this is the hydrogen shielding gas. Okay, and this is the filler metal that will provide additional metal to the molten weld pool. So this is the molten weld pool. So what is happening during atomic hydrogen welding process? See, between these two electrode, non-consumable tungsten electrode, an electric arc will be created. Due to the temperature of the electric arc, the hydrogen surrounding this area undergo an endothermic reaction, and the hydrogen molecule that is converted into hydrogen ions, that is H plus and H minus. When these ions contacting with the molten workpiece or base metal, these hydrogen ions again recombine. So initially H2 converted into what? H plus and H minus. That is a endothermic reaction. That means heat will be absorbed. Almost 422 kilojoule heat will be absorbed during this process. Okay. So next one, when these hydrogen ions contacting with the cool base metal, hydrogen ions again recombine and hydrogen molecule will be produced. That is an exothermic reaction. Exothermic reaction means that will liberate heat energy. So this will again combine and form hydrogen molecules. That is an exothermic reaction, and that will liberate heat energy, almost 422 kilojoule, and that have a temperature of 4000 degrees Celsius. And that heat energy is used for melting the base metal to be jointed. And if we require to add additional material to the molten weld pool, this will be adding through filler material. So this is the principle and main components in a atomic hydrogen welding process. So what are the advantages of atomic hydrogen welding process? Welding process is faster. Intense flame is obtained, which can be concentrated at the joint, hence less distortion occur. There is no separate requirement of shielding gas. Hydrogen envelope itself prevent oxidation of the metal and tungsten electrode. Workpiece do not form a part of the electric circuit. So these are the advantages of atomic hydrogen welding process. Then disadvantages. Welding speed is less compared to MIG welding. Process cannot be used for depositing large quantities of weld metal. Welding process is limited to flat portion. Flat portion only atomic hydrogen welding can be performed. Post welding process is high compared to welding process. See, post welding process means heat treatment process should be done after doing hydrogen welding process. So application. They are used in joining parts, hard surfacing and repair of dies and tool. Atomic hydrogen welding is used where rapid welding is necessary in stainless steel, non-ferrous metal and other special alloy. Atomic hydrogen welding are used in welding tool steel which contain tungsten, nickel and molybdenum. The main application of atomic hydrogen welding is it is used for welding tool steels, tool and die materials, tool steels which contain tungsten, nickel, molybdenum, which is very hard. Okay. So in this video I have discussed about atomic hydrogen welding, principle of atomic hydrogen welding, process, atomic hydrogen welding process, advantages, disadvantages and applications. Thank you.